Hello, this is Tom Klepper, and welcome to the Part 4 of the Basic Electrical Circuits course taught at the Route 9 Library and Innovation Center. This part we're going to learn about programming the Arduino microcontroller. This class was taught on October 22nd, and I'm just recording it this weekend so we can upload it and you guys can watch it later. Alright, so we're going to start off the course or class by going over the Arduino once more. Talk about proto boards, intro to the Arduino integrated development environment, and then jump right into learning how to code or program in the C programming language. So the Arduino microcontroller board, again, is programmed using the C language. We're going to be taking some kind of input sensor or transducer, like measuring light or vibration or touch or anything, or outputting to an LED or a speaker, etc. And then we're going to be interfacing that to Arduino, and then we're going to learn how to program that using the C language. Okay, so here is the Arduino Uno board. This is the one I selected. You can get these for about 10 bucks on the internet. So let's kind of walk through it and point out the most important part. So the USB cable, when you go to plug it in a computer, goes into this port. And there should be a USB cable with your Arduino. This is the reset button right here. This is essentially if things get locked up or you want to simulate power-up mode, you press the button and it resets the whole program. Here's a ground input. Here are some digital inputs and outputs. Here is a place for some analog inputs, and then finally a couple more ground spots here, and then a +5. You can use this to power up any external sensors or even a pull-up resistor, etc. I think we mentioned that last time. This +5 can supply maybe 500 milliamps if you need it to. The power comes from the USB port. You do have to make sure that the whole printed circuit board sits on an insulated surface. So there can be no metal underneath of it at all because the pins are exposed. You could burn out your board, or worse, you could burn out your USB port on your computer. So you really got to make sure that this is touching nothing metallic. If you need more power, there's an optional 5.5 millimeter OD, 2.1 millimeter ID DC input jack right here. And it's a positive center terminal configuration. And just make sure that the voltage going in there is between like 6 to 12 volts. And it does have an onboard LED, and it's co-located with pin 13 here. And again, if you need to learn more about Arduino, here's the website, and you can learn everything you need to about it right there. So let's talk about prototyping breadboards. So these are used a lot for quickly putting components together, hooking them to your Arduino, and they're basically made up of a lot of sockets that you could plug components and wires directly into. But the important part about this is knowing how they're connected. So this first horizontal row right here, and these are two different proto boards. There's a smaller one and a larger one. They're connected together, and just like these are connected together. So the rows are connected together by themselves. So that one's connected, that's connected, just like it's shown. That row's connected, this row's connected. They're obviously not connected to each other, just to the 5 in a row, and these 5 in a row, and so forth down the line until you get all the way down. So essentially these 5 are connected, these 5 are connected, and the same on this board as well. Now these outer ones, this column here is connected, and this is meant to maybe put the +5 of the Arduino maybe into this pin, and then you can tap into that anywhere along this single column for +5. And then this column is connected, and it's intended to be connected to the ground of the Arduino. Now on this side, this plus is connected, and then this minus. So obviously this plus and this plus are not connected together. You would need to connect them together yourselves. So this just shows you how each of these pins are connected. If you're unsure, you can use a multimeter to verify that what is connected to what. And just to let you know, the diameter, the best diameter of a wire going into this is about 0.25 inches, or a 22 gauge solid center conductor. So this is what we're going to use to connect our parts to the Arduino. So this is the Arduino software, or we call the integrated development environment. So if you fire up your program, you'll see something like this. And there's 3 main sections to take note of. Again, this is called a sketch. and it's written in the C programming language. The first section is where we're going to declare our variables, which is right here. So we're going to declare any variables in this part before this void command. The next is the setup section. So this little part here is where we put all of our code to initialize variables or initialize ports, etc. And then the final one is the loop. This is the main part. This is where you're going to put most of your code. And this loop essentially is just going to execute all the code to the bottom part here and then come back and re-execute it again over and over and over again until you either hit the reset button or you turn the power off and turn the power back on. When you turn the power back on or hit the reset button, essentially this goes to the top and just re-executes this all the way down and then gets stuck in this loop. So anything that's initialized, this only gets run once at power up or when you push the reset button. So let's go over a few instructions. First, here's some variable types. There's many more. These are the key ones that you're going to use. The first one is an integer, which we call an int, has a max of about 32,000, and these would be numbers like 1, 2, 3, 4, 0, and then -1, -2, -3, all the way up to 32,000. This is probably the most popular or most used variable type, and you declare it in the top section of the code like this: int space, then your variable name equals, let's say, whatever you want to initialize it with, and then with a semicolon. All of these statements end in a semicolon. There are some rules about how you name variables, like you can't start the name of a variable with a number. Some people like to use conventions like whether you use small letters or capital letters. I'm not going to go into that right now. Just you can Google that if you want to learn more about that. The next one is a floating point. They call it float, and this is if you needed a number to be saved as a decimal point. So in this case I have float pi, the constant pi equals 3.14. I think there's about 6 or 7 decimal places it'll keep, and it'll go up to a pretty large value. Again, a plus number and a minus number. And then finally, this is the Boolean type, or BOL. This kind of a variable can only be a true or a false. So this is stating bool. I'm calling my variable status, and I'm initializing it to false. This again is also one of the most important types of variables that you're going to use in programming. So let's go into Boolean tests. So these are the things that are used a lot. They're a little tricky. So they're a little tricky to understand. Once you get the hang of it, you're going to go, oh, I get it. But let's kind of go into what a Boolean test is. And essentially what a Boolean test is going to ask a very simple question. Is the statement within the parentheses true or false? It can either be one or the other. So here are the operators. So these are the different operators. And in this case, if you say x equals y, what you're really asking is x equal to y. If I said x exclamation point equals y, you're saying is x not equal to y? X is less than y is an obvious one. X is greater than y. X is less than or equal to, or x is greater than or equal to. And again, what they're asking, like in this last one, they would say, is x greater than or equal to y? The answer to all of these is either yes or no, or true or false. There's only one of the two answers. These are comparison operators with a Boolean outcome of either true or false. So let's kind of take a look at a couple examples. So here we have x equals y. The double equals means it's a test for is it equals. A single equals is used up here as an assignment. So you notice int x equals 4, it's saying we're going to define a variable called x, make it an integer, and we're going to put 4 in it. So we're assigning 4 to x. Here we're asking, is x equal to y? When we go up here, x is 4, y is 5, so that would be a false statement. Here, status equals false. So they're saying, is status equal to false? We go up here, status is initialized to false, so that is true. So that statement within the parentheses is true. Here is x less than y. X is 4, y is 5. Yes, that is a true statement. Is x greater than z? X is 4, z is 6. So x is not greater than z, so that statement is false. You can almost say, it's saying, is x greater than z? If the answer is no, then it's false. If x is greater than z, if the answer is yes, then it would be true. Is y not equal to z? Well, no, they're not equal. So that it's a true statement. Y is not equal to Z. And then is status equal true? Well, status is equal to false. So status equals true would be a false statement because if you say is status equal true, the answer is no or false. So that's how you deal with Boolean tests. You'll see how we'll use them in the next couple of slides. So here's a few more instructions. These are Boolean operators. So again, this is, the exclamation point is a not X, meaning that X must not be true or X is false when you say that Boolean. Like we saw that before with the exclamation point equals. It's not equals. This one is saying is X and Y true? So in order for this statement to be true, X would have to be true and Y would have to be true. They both have to be true. If any one of them is false, then this whole thing is false because they both have to be true in order for this combined expression to be true. And this third one is they're asking is X or Y true? So either X or Y must be true for this whole thing to be true. So if X and Y are false, then they're both false. But if X or Y is true, then this combined expression is true. So these are used to kind of say, I'm combining two Booleans in a way that's either this and that or this or that. This is an and or an or operator. So let's take a look at some of these. We're combining these Boolean tests. So we go, and this is kind of reminding us ourselves what X, Y, and Z and status is. So they're saying, is X equaling Y? The answer is no, it's false. And status equals false. Well, that is true. So this is saying that's false, that's true. But when you combine them, what you're asking is this and that true? Well, no, it's not. That's false because this is false, this is true. They would both have to be true in order for the combined Boolean test to be true. So this is false. This one is X less than Y? Well, that's true. And is status equal to false? That's true. So if that's true and this is true, then the combined is true or is also true. Let's look at this one. So this is saying, is Y not equal to Z? Well, they're not equal, so that's true. And is status equal to true? Well, that's false. So this, even though this is true, this is false. So these would both have to be true in order for this to be true. So the combined is indeed false. Here is X less than or equal to Z. The answer is yes, so that's true. Or is Y equal to Z? Well, that's false. But since this is true, it's saying is this true or is that true? So this is true, this is false. This is true, so that means the or is true. The combined expression is true. Here is X equaling Y. Well, no, so that's false. Is status equal true? No, that's also false. So since that's false and that's false, the or of the two is also false. So this is how we combine Boolean tests, and these can go on as well. They don't have to just combine into two. We'll see how these are used next. So this is probably the most powerful statement or I guess instruction used in your programming. It's called the if-else statement, and let's kind of go through it piece by piece to see how it works. So it's an if, then you have the test, the Boolean tests in parentheses, then you have an open bracket, and the whole thing has a closed bracket. So this if open bracket closed bracket defines this statement or instruction. They always have to have this bracket here in this closing bracket. So what it's asking is X equaling to Y and is status equaling to false? So is X equals to Y? No, that is not true. They are not equal, so that's false. Status equals false is true, but since this is false and that's true, they both would have to be true. So that means this overall combined is false. So if this first test is false, what this statement says, if this whatever's in these outside parentheses, if this is true, then execute this code right here. When you're done executing the code, jump to the very end parentheses, jump out of your loop. Okay? So they're saying basically if this is true, everything in here is true, do this code and then jump out of it. However, we know that this is false. So if this is false, jump down to the next part, and then it's going to go, oh, else, and then here's another if. So else if x is less than y, which is true, status is true, well, that is not, that's false. So we know that this is false, but this is true, and this is an or statement. So this is true or false, so that's true. That means that this everything in this parenthesis is indeed true. So that is indeed true. So it's a if else if this whole thing is true, which it is, then go ahead and execute this code, which it will. So it'll execute this code when it's done, whatever's in between this bracket and that bracket. There can be multiple lines of code here. It will jump out of the thing. Now, if for instance this was false, it would just go down to this next if else, and it would look at this expression. And finally, if all three of these were false, it would go and do else. So it's kind of saying if this is true, then do this. If not, go to this. If this is true, do this. If not, go to this one. If this is true, do this. If not, else, go to this, and finally execute this code if none of these were true. So this is like the kind of the catch-all for this if-then statement. So this is a pretty complete. Most if-thens would just be a simple if something, then do this. But this has the if and the else ifs, and this can go on and on depending on what you're actually trying to do. You have different scenarios you're trying to test for, and this kind of just shows you that this first thing is the combined parentheses, right? So it's you could have multiple Boolean tests and you can combine them using these operators, and then if ultimately if this is true, it's going to go and execute this code. So that's an if-then statement. Again, a little tricky. I think once you do it a couple of times, you get it, which just takes practice. Here's a few more instructions. So here's a special version of the if-then. It's called the switch case statement. Okay. So what this is kind of neat, and you can kind of see how you would use it. So it's saying switch x, and x is a variable. Let's say in this case it's an integer, and I think if I remember correctly, we had x equaling 4. So it's saying switch x, so on this x variable, and you're going to have this in these beginning and close brackets. It's saying case 1 or case 2. So it's saying if x is equal to 1 or x is equal to 2, execute this code, and then break means break or get out of this and move on to the next line of code down here. So in our case it's 4, so it's not 1, it's not 2, so it would go to the next case. And so as case, this is asking, this case 3 is x equaling 3 all the way to 10. So 3, 4, 5, 6, 7, 8, 9, 10. If it is one of these, which it is, then it'll go ahead and execute this code right here, break, which get out of here. Now if it just happens not to be anything, let's say x was 11 or something, it would come down and do this default. It would finally execute this code right here. So that's a very powerful instruction. The next one are called for loops. So this is what if you want to loop and do a bunch of things a specific number of times. So what this is saying is for everything in the middle, you're going to execute everything between these brackets. Here's the code you would put in here. Again, this is going to be multiple lines of code. And what it's saying here is declare this variable I as an integer, set it equal to 0 as an initialization. So it's integer I equaling 0, and then it's saying kind of you go from here, jump over to here, it's saying increment I. So I plus plus basically is saying take I and increment it by 1. So you're going to do I equals I plus 1, and you're going to keep on doing that as long as I is less than or equal to 10. Let me go back. So so essentially what it's going to do, it's going to initialize I to 0, it's going to execute this code, it's going to come back, and then it's going to go, okay, increment I by 1, so now I would equal 1, and go do the code. It's going to come back and go increment I to 2, go to increment I to 3, do the code all the way. It's going to increment I to 10, so once it gets to 10, I equals less than equal to 10, great. It's going to go through and it's going to execute this code while I equaling 10. When it comes back and increments I to 11, it's going to go, oh, Nope, that doesn't fit in our little test here, so it'll jump out and go to the next set of code that you have beneath it. So that's a for loop. There's a couple other loops that are called do and while loops. Now, you would use one versus the other depending on where your test is. So this one is saying while x is less than 10, less than or equal to 10, execute this code. Execute, and then here I'm going to increment x, and it's going to go back and do the test again. So it's just going to keep on doing this, increment, until it gets x equal or less than a 10. When x equals 11, it's going to go back and go, oh, nope, doesn't fit, so it's going to move on to the next. Now I reinitialize x to 0 right there. And then this one is kind of saying do, so you're going to first do the code, increment in x, and then test for is x less than or equal to 10. So essentially they're very similar, but you would use one versus the other depending on where you want the test done. So now we're going to analyze a simple program. This is the example 1 program that you're going to load, but we're going to go through the program and kind of learn a little bit more about the C language as we go through. So the first thing you're going to notice is I have some funny stuff here, and these are comments. There's two different kinds of comments. One's called a multi-line. You begin with a slash asterisk, and then everything after that is just commented, and it's going to continue to go until I hit an asterisk slash. Now what this means is the compiler is going to ignore all of this text here, and this is there for your benefit. You're going to put in as much comments as possible so that you can remember, or somebody else looking at your code can figure out what you're doing. So the more comments you put in, the better. You can't put enough comments into a program. There's another kind that's called the end of line that's using this slash slash. So here you see that I have an integer called LED output pin. I've set it equal to 13. There's our semicolon. And I have slash slash built-in LED is on pin 13. So this is a comment at the end of the line. It's going to ignore all this text. So you may want to put just a small little comment right on a line, and that's what this slash slash is for. Again, you can see that we're ending our statements with this semicolon. And then finally we have another integer. I'm calling it val, setting it equal to 0. Here's a boolean. I'm calling button push, setting that to false. And then finally another integer called count, equaling initializing to 0. This push button input pin is 12. Just to let you know where that is on the board, it's that, digital inputs, it's that 12 right here. That's the specific one that we're talking about. That's how you access it. And then again, some more variables that were used in the program. So we're going to move on to the next section, the void setup. So this is again where we're setting up. Now you notice we can set up or initialize some variables in the first part. Here we're setting up things like the serial port. So we're going to, this is the actual serial port going from the cable from the USB of the Arduino to the USB of your computer. And not only are we going to use that cable to program our Arduino, we're going to use the same cable and connection to talk from the Arduino back and forth to the computer once we've loaded our program. The way we initialize that is serial.begin, and I like to use 115,200 as the baud rate. This is the bits per second rate of the serial port. I'm not going to get into too much about this nomenclature. This is a library. You can go on to Arduino's website and look up serial port, and it tells you exactly how to utilize this serial library. Here's another command called pin mode. I'm going to set the mode of the LED output pin to output. So remember, we said that this LED output was pin 13. And then this is just nice because I can go back in the initialization and change that pin number, and it'll change it all the way through the programming in our program programmatically. So LED output pin we know is equal to 13. We're going to make it an output because we're driving an LED, and then I'm going to digital write that pin with a low, or I'm turning it off. I'm making it a 0-volt output. And then here's another pin mode we're calling the push button input pin. Now remember, we've made that pin 12. It will be our input for our push button, and then we're making it an input underscore pull up. And what I mean by that, it's got, I guess I have comments here. So that's LED, turn the pin off, and then So this one is the push button input pin, and we're making use of an internal 20 kilo ohm pull-up resistor. So if you remember from our previous class, I talked about if you want a push button input, you're going to use an external pull-up resistor to +5. We talked about why. And then when you connect the push button, you're pulling that connection to ground. This Arduino has the ability to have an input pull-up resistor, and that's just for convenience, so you don't have to worry about hooking it up, adding another component. It's already built in, so why don't we just go ahead and use it. Okay, so here is our main program loop. And again, this is going to get executed over and over and over again very fast. I mean, like, microseconds, tens of microseconds kinds of fast. And so let's kind of go through it. So first what we're going to do is we're going to assign the val to digital read the push button input pin. So remember we said that that push button input pin will either have a +5 volt if it's just sitting there, or when you push it to ground it'll have 0 volts, which is the same as saying the +5 will be a 1 as far as the input. So val would be 1 normally. If you ground it to 0 volts, then val will be 0. So val is going to take on the value either 1 if the button's not pushed, or 0 if it is pushed. So then we ask, is the button pushed? So we're using an if statement. And here we're saying if val is equal to 0, which is saying, is val pushed? Now normally if you're just starting the program, it's not going to be pushed. So this would be a false statement. Because and button pushed equals false. So if you remember, we created this button pushed and initialized it to false, and if the previous. So this part is true when you first run it, but this part is false. So it's saying if this and this is true, then execute this code. But it's not. This is false. So it's actually the first time we run this, this is going to jump over this whole section of code and move on to this next line of code. So it's going to say if val equals 1, which it is because it's high, execute this code. So it will. So button push is false. So it's assigning the value of false to button push, but it already was false. So no harm, no foul there. And it's going to say digital write, make the LED output pin low. Now it already was low. So again, no harm, no foul. And then you'd get done the loop. When it gets done down to this bracket, it's going to go back up to the top and re-execute the code again. So it's going to keep on executing this, nothing's going to change. It's going to keep on skipping this and executing that every single time we do it. Except for all of a sudden now we're going to push the button in, and when we do that, val will all of a sudden now it will equal 0. So that will be true. And remember, button push was false, so that's true. And hey, both of these are true, so the whole thing is true. Now we go ahead, we are going to execute this code. So the first thing we do is we're going to make button pushed equal to true. So we're going to assign true to button pushed. We're going to say count equals count plus 1. We're going to increment our counter. You could also write this as count plus plus semicolon. Remember, count plus plus is the same as saying count equals count plus 1. Digital write means that we're going to make the LED output pin high. So that's making it +5 volts, which will start current flowing through our resistor into our diode and make our LED light. So by making this high, our LED should turn on. We're going to serial print, so we're going to output these letters count equals, and then finally print line the value of count. So theoretically, if the first time we go through here, count started off as 0, we're adding a 1, so now the first time we go through, count will be 1, which means, hey, we've pushed the button once. And then it exits the thing. So now it says if val equals 1, which is not, because remember, if val was 0, so that means this is false. It's going to skip over this code. So we just ran this once through with val equaling 0, and we did this following bit here. So we're assuming the button is still pressed. So when we come back to it, it reads this value. It'll still be 0 because the button is still pressed. Comes down. Is val 0? Yes, it is. But remember, we switched button push to true. So now this is now false. So that's still true, but now this is false. So it will now skip this code. So it's not going to execute this, which means you can see this code really only executed once because of this Boolean variable here prevents that from being executed more than once. So this will only be executed once while val is 0 because they switch button push to true. Come down here, val 0, so this is false. It's going to skip this code. So while the button is pushed, it's going to skip both of these sections of code and just keep on looping around doing absolutely nothing until you magically release the button, and now digital read will return a value of 1 into val, and then it'll come down and go, oh, okay, val equals 0. Nope, it is not. Button push is true. So yeah, that's a false and a false. Let's skip that code. But now val is 1. So okay, now reset button push to false and make the LED pin low. So turn off the LED. Great. So now we reset button push to false. The LED is off. We come back and then we test this again. So val is still 0, but now button push is true. So once again, it's going to skip this code, 2 sets of code. It's going to skip this code, run this code until you push button again. So that's how this program works. It's kind of a goofy program, but pretty straightforward. Gives you a flair for how you would use variables, how you would read digital inputs from pins, how you do tests using the if statements. We can assign here, we do a counter. We're using the serial port. So it's got a little of everything in it. We're writing to the pins to turn the LEDs on and off. So it's kind of a basic little program. Yeah, so I talked through that, and yes, val must be 1 in order to execute this code. So that's kind of the analysis of our simple example 1 program. Let me go over one more instruction type. Let's say you want to define your own function. So let's go back to this. Defining 2 variables, a equaling a 3, an integer, b equaling 4, and a third one called answer equaling 0. So in our setup program, I'm going to initialize the serial port to 115, 200 baud. Okay, and now let's go and take a look at a simple program. Here's the loop. That's all the loop does. First it says delay 5,000. So the delay command is another one of these commands supported by Arduino that delays for so many milliseconds. So here it's delaying for 5,000 milliseconds or 5 seconds. Now why did I put that in there? I just felt like it, but it just kind of shows you that. So it's not going to do this loop really quickly. It's going to delay for 5 seconds. Then it's going to say answer equals multiply a and b. So these are variables going into this multiply function that I've defined, and then I define another function called output answer. So essentially you can see what's going on. I want this function to multiply a to b, put the result into answer, and then have answer go and be outputted. And then it's just going to run this over and over and over again every 5 seconds. It's going to run this. So notice the void loop has the beginning bracket and the end bracket. So these definition of functions go outside of the loop. Here's the first one. It's called int multiply. So I'm saying my function is going to return an integer. And it's going to take an integer input x and integer input of y. Notice these are different variables, because here what I'm saying is call the function multiply with a and b. Here it's going to put a into x and b into y. Now I'm in my function. In my function, again, started by the opening bracket and closing bracket, integer result. So I'm defining a new variable called result. Let result equals x times y. Here's the semicolon. And then return result. So when you define a function such that I'm saying this function multiply will return an integer, I obviously have to return an integer. Right? I can't not return something if I'm telling it that, hey, take this variable x, take this variable y, and return some kind of an integer. Now what kind of an integer? What's the result? Well, that's defined right here. I define an integer. The result happens to be x times y. It could be whatever I want it to be, depending on what the function does, and then return this result. So you can see multiply a by b will multiply a and b and return an integer value that goes into answer, which itself is also an integer. You see here how things need to be consistent in terms of the variable types. And then finally, here's another thing I'm calling output, where it does have an input, integer number. Now notice this void here in front of it, so it says void output. We've seen this before, right? Void loop, void setup. What that void means, I forgot about it. So function inputs returns. Yeah, so what this void means is that nothing is returned from output. So here I'm saying I'm going to return an integer for my multiply function. Here I'm not returning anything, so I use the word void. But what output does is it does take a variable called number as an integer, comes in and then says over the serial port print number equals, and then print the actual number. So if you look at our program, what it's going to do is going to multiply A and B together, put in an answer, output answer to the serial port every 5 seconds. So that's how you define your own function. So now what I want you to do is actually connect the Arduino Uno microcontroller board to your computer via the USB port. And I want you to load each of the 3 example programs into the Arduino software, the Arduino IDE. And what I want you to hook up is, we're actually not going to use the 5 volts. And we're not going to use this pull-up resistor, because remember, we're using there's an internal pull-up resistor in this chip. But I do want you to hook up the following. I want you to take a wire from 12 and maybe connect that over to the prototyping board. You're going to connect a wire from here to the ground of the prototyping board, the ground strip, the ground, that vertical column. And then I want you to connect a wire from pin 11 to the prototyping board, have the resistor go from one independent row to another, and then the LED hooked up where the anode goes to the resistor, and the cathode will go to ground. Again, these 2 grounds go back to this ground. So these are literally connected together. So what I want you to use for the push button are just 2 wires. So in other words, you're not going to have an actual button. You're going to have 2 wires that are kind of dangling there. And then what you're going to do is you're going to touch the 2 wires together. Essentially, you're bringing this 12, you're touching it to ground, is essentially what you're doing. So this right here is all you're really hooking up to the board. So we're going to have an external red LED and an external push button. So go ahead, and again, from here on out, it gets a little clumsy because it's better done in person. In the class, I actually went through this. We looked at the screen, but I'll just go ahead and continue through the slides, and you can go ahead and do this on your own. So a couple notes about setting up the Arduino IDE. When you fire up the program, what I want you to do is go to Tools and select Board, and make sure the Arduino Uno is selected. So make sure the Arduino Uno is selected. Okay, that's the first thing. Second thing, under Tools, Port, make sure the COM port selected is the one that actually has the Arduino Uno connected to it. So when you first connect the Uno to your computer, it'll automatically load the drivers. It'll automatically load a virtual serial port. This may be COM4 or 6 or 9, doesn't really matter. But it's going to assign a COM port to your Arduino. That's the one you want to select. And then finally, when you load up your program and everything's set, and you made sure that the board's not touching anything metallic, and you're not going to short anything about, and you've loaded up your program, to compile the program, if you just want to compile it, you would hit this check mark here. If you want to compile it and upload it to your Arduino, you simply just connect this button. And as long as this is selected and you got the right COM port and you compile this, you're going to compile whatever example program you have and upload it to your Arduino, and you're up and running. That's pretty much it. All right, so let's take a look at example 1. This is what I'm calling a non-debounced input. So this is the program that we just analyzed piece by piece before, okay? And essentially what it's going to do, it's going to take when the button's pushed, which is essentially you grounding pin 12 to ground, it should output this count equaling the number of times you press the button or you grounded it, and make the LED turn on. And when you disconnect it, the LED should come off. What you want to do before you do that, though, is press Control-Shift-M to bring up the serial monitor. You can also do this through the drop-down menu. And then I want to make sure that in the lower right-hand corner, this is selected as carriage return, and that 152 baud or bits per second is selected. So this is keep these at carriage return and 115 baud. As soon as you've done that, now I want you to go and take the wires and just press it together once and release it. So you're going to take pin 12, connect it to a ground lead once and release it. Now theoretically, if you went through this code, this should only happen once, right? When it grounds, you get count equaling 1, and it's going to release until you do it again. However, when you do this, just grounding pin 12 once will cause several counts. You might see, 1, 2, 3, or 1, 2, 3, 4, or something like that. What you're seeing is actual ground bounce in action. This is what we talked about in the previous class. This is the chatter that when you go to bring the two wires together and touch it, it's going to occur a bunch of times. And you may even see it not only when you first touch it, but as you're releasing it, you may see a couple more counts because you're getting ground bounce as releasing, which means the thing's actually turning on and off a bunch of times as you're bringing it down and closing it or touching it and releasing it. So that's the actual hardware test showing you that ground bounce is real using this program. So this is not a really good way of coding up the input of a pin, right? Because it could happen a whole bunch of times. You don't want that. You only want it to happen once. So example 2 is what I'm calling a debounced input program. And so here is the code to do that. I'm not going to go through it per se. I did in the class, but you can kind of see that I'm having some of these like state variables that goes through, and it does some checks. But I do have a timer going on here. So essentially, the first time the thing is pressed 0, kind of like we did before, I'm starting a timer. So millis is a little again, it's a function that's inside Arduino that returns the number of milliseconds since the Arduino has been turned on, and it can I think millis can go for some like 50 days because this is a really big number. This can go to big before it wraps around. So this is the number of milliseconds, and essentially what it does, you can see, is after this difference of the new millis minus the millis after change is greater than 100, then it creates this new state variable. So essentially what it's doing is waiting 100 milliseconds until after the first time the button's pressed. So it's allowing 100 milliseconds for all of that chatter to complete before it goes, oh, okay, oh, then you are pushed, then go ahead and execute this code. Turn the LED on, do your count and output the count. So the only thing I've really added here is this whole timer function. Now remember from before, millis, the actual ground bounce I think was only a couple of milliseconds long, so obviously 100 milliseconds is way overkill. And you could change that to what you want, really. It could probably be 10 milliseconds for all that matters. But and then the same kind of thing, I have the same thing happening here when you go and release it. So it waits for 100 milliseconds until after the first release happened before it goes ahead and says, oh, let's go ahead and reset the variable so it can all happen again. So when you go ahead and same kind of deal, after you brought this program in and you've compiled it and you've uploaded it, make sure you can Control Shift M to bring up the serial monitor. One little thing you may want to do is when you go to bring in example 2, I think it keeps example 1 open in a separate IDE. Go ahead and close that so you only have one version, just to make it clean, only one version of the Arduino IDE open at a time. But now when you go ahead and do this, you press the you ground pin 12, you press it down once and release, you will only get count equaling 1. And if you do it again, you'll get a nice clean count equaling 2. And so this should follow exactly the number of times you press those wires together or you ground pin 12. So this is a software debounce kind of thing. There's lots of ways of doing this. This is just one way of doing it. So that's how you would software debounce an input pin. So this is a very clean way of making a good input pin, push button. So example 3 I'm calling a not so simple program. So I'm not going to go over the code, but here's what I want you to do. Bring it in, compile it like we talked about, press Control Shift M to bring up the serial monitor. Again, make sure carriage return and the 150 baud is selected, and make sure it's its own IDE, that there's only one version of the thing running. And then what I want you to do is type some commands into the input box of the serial monitor and press the return key. So first what I want you to do is type an I. It can be either lowercase or capital, and then press return, which is the same thing as typing I and pressing the send button here. But press I and return, and like no quotes around it, just an I. Don't put those quotes in it. So type in I, press return, and that gives an information string. If you type in an L and press return, so just the letter L and press return, you'll make the LED, our red LED, toggle on, and if you type in L and return again, it'll toggle off. So what we're doing is if you look at the code we've written some program. There's a program in there that allows you to interact with the Arduino and make the Arduino do stuff. Like here, I'm having it return an information string about the Arduino. Tell me something about yourself. And here I'm telling the Arduino, toggle the LED on and off when I type in L. If you type in a P, it returns the number of times the Arduino has been powered on or reset. So when you type in P and press return key, you'll get either 1, 2, or 3, the number of times it's been turned on or off. If you don't believe me, press the reset button, wait for a little bit, and then press P again. You'll see that it returns a number that's 1 higher because you've reset the Arduino. I think I have in there, if you press P0 and return, it resets that. This is actually storing this in the EEPROM of the Arduino. So just something you can do. If you type in L and then the plus, you'll take the LED into this flicker mode. So what it's going to do is it's going to simulate a candle flickering using the LED, all in just using code. It's called the pulse width modulation part of the Arduino. This is a really cool effect, and I've added some code in there so you can play with it. So it'll boot up in a certain I guess state. And it's not bad. It's not a bad LED flicker. If you wanted to play around and modify with it, then you can try these two commands. You would type in B XXX, where XXX is either 0, 1, 0, or all the way to 250. So it could be 100 or 131 or anything from 10 to 50. And what that's telling you is it's setting the brightness level. So, if you type in 010, I think that's the brightest part. So it's going to be, every time it changes, so it's randomly changing brightness levels. You type in 10, it's going to be pretty bright all the time. So that's kind of the depth of the brightness change. You type in 250, it's going to change its brightness levels between 0 and 250 randomly. So you could get it so it's pretty bright or not so bright. So this is like 250 would be a really big brightness change, the depth of brightness, and 10 would be a very little brightness change. So try it, see what happens. Put in a different value of B. And the next one is D XXX, same thing, 010 to 250, and this sets the delay between the brightness change. So there's a random, here it's a random brightness level where the height of the brightness level is determined by this B command, and then the number of times it changes, so the actual milliseconds between the change, that's what this delay is. It's giving you a random amount of change in milliseconds that it will change the brightness level. So this combines, so the brightness level, randomness change versus the random delay creates the flicker. And then finally, I just threw in a command A, press A return, it returns the analog voltage level at analog pin 0. It'll give you a number between 0 and 255. Actually, I'm not sure that's true. Should be 0 and 1024. That may not be true. The reason why you'll get a number there to begin with, because remember, it's not connected to anything, but the reason why you're getting something is because the analog pin 0 is floating. If you don't believe me, go ahead and ground analog pin. So take analog pin 0, take a wire from it to ground, be careful, make sure you're connecting the right one, and go ahead and return A, and you'll get a 0 back for sure. So I think that's about it for example 3. Go ahead and look through the code, and again, this is a little tricky because in the class We went through it in detail. I'm just kind of outlining it. Look through the code. I actually just let you know where this code came from. I use this as a starter code for almost all of my projects because it allows me to set up the Arduino after I program it via the computer. It also lets me to write a computer program to communicate to the Arduino if I want to do some, let's say, home automation project or something. So essentially that completes the course. Congratulations. So you've gone through all four of the basic electrical circuits class. And I guess what I'd recommend now is to find a really simple project. Don't look for something that's complicated. Start with something simple that involves a sensor or two and an Arduino, just to get the idea of how you put together a project, how you do the programming. If you need some examples, there's so many examples online, or talk to us on one of the Maker Mondays. There's a number of us there that can help out, and hopefully this is get you enough to just to get started. And thanks for hanging in there. You have a good one.